Imagine for a moment that there is something in the universe spinning faster than helicopter blades, faster than anything you can imagine. Now imagine that this thing has 2.5 times the mass of our sun, but could fit entirely within the limits of New York City. It seems impossible, doesn't it? But this is exactly the terrifying reality of Pulsar J09520607, the heaviest neutron star ever discovered by scientists. This cosmic monstrosity spins at an incredible 707 rotations per second. To give you an idea of how absurd this is, think of your kitchen blender running at maximum speed. Now multiply that speed by hundreds of times. It is literally faster than jet engine turbines. But here is the question that won't go away. What makes this star spin at such an insane speed? And more importantly, does it represent a real threat to us here on Earth? The answer will leave you speechless. This pulsar has an energy source that is both fascinating and terrifying. It is literally devouring a white dwarf, which is what remains of a star that once shone but has now become a victim of its vampiric companion. The white dwarf is too close to the pulsar because of the immense gravity and powerful radiation. Its matter begins to be torn away, transforming into a superheated plasma flow that runs directly toward the neutron star. The pulsar absorbs this material, gaining even more energy for its rotation and radiation. Meanwhile, the white dwarf rapidly loses mass, becoming weaker and dimmer. It is as if it were evaporating, delivering its matter to its more powerful companion. But this process is dangerous even for the pulsar itself. Gradually, it accumulates matter and approaches its critical mass. And here is where things get really scary. If this star exceeds its limit, its matter will no longer be able to resist its own gravity. In this case, the pulsar risks collapsing and transforming into a red giant. When the temperature and density in the core reach a critical point, a supernova explosion occurs. And man, when that happens, it won't be pretty to see. But before we get into what would happen if this cosmic time bomb exploded, you need to understand how bizarre a neutron star really is. After a giant star explodes in a supernova, all that remains is its core, now transformed into a neutron star. The mass of such a star is typically about 1.4 times that of our Sun, but its size is absolutely mind-boggling. Its radius is only 6 to 7 miles, almost 70,000 times smaller than the Sun's radius. Imagine the Sun shrinking until it becomes the size of a small city. The material of these stars is the densest substance we can observe in the universe. It has such an unbelievable density that if, under some fantastic circumstances, a piece the size of a sugar cube were placed on Earth, it would instantly pierce any surface, drilling through the planet's layers until reaching the core. Compared to this, the density of everything around us is practically insignificant. Another amazing property of a neutron star is its temperature. On average, these stars reach billions of degrees. Some scientists suggest that inside neutron stars, protons and neutrons decompose into even more fundamental particles called quarks. If this is true, the depths of these objects could be composed of mysterious quark matter.
But what makes these stars truly terrifying is their immense gravity, caused by their extreme density. The gravitational attraction of Jupiter, or even the Sun, which keeps an entire planetary system in orbit, pales in comparison to what happens near a neutron star. The only stronger gravitational attraction found in the universe belongs to black holes. Neutron stars are so incredible that they are rightly considered among the most exotic objects in the universe. However, as it turned out, they come in a variety of types, and some are so unique that when scientists first discovered them, they thought they could be signals from extraterrestrial life. In 1967, British scientists detected the first pulsars, and thus pulsars got their name. A neutron star is not just an extremely dense and incredibly hot object, but also one that spins at an extraordinary speed. This effect arises due to the conservation of angular momentum. To better understand how this works, imagine a figure skater spinning on ice. When they pull their arms close to their body, their rotational speed increases dramatically. A similar process occurs with a neutron star. As a star collapses under gravitational forces, its diameter shrinks drastically, causing it to spin tens or even hundreds of times faster than regular isolated neutron stars, transforming them into pulsars. As they spin, pulsars emit powerful and destructive beams of energy from their poles, producing sweeping lighthouse beams composed of radio waves, visible light, X-rays, and gamma rays. The flashes of these beams are detected on Earth, creating a cosmic lighthouse effect that resembles an artificial signal sent from deep space. Now, returning to our terrifying protagonist, Pulsar J09520607. Normally, neutron stars have a mass of about 1.4 times that of the Sun. But this pulsar's mass is almost 2.4 solar masses, taking it close to the point of no return. According to recent calculations, if a neutron star reaches a critical mass of 3 solar masses, it can no longer resist its own gravity and will end up collapsing into a black hole. For a long time, scientists sought to understand why this neutron star spins so fast and has such massive weight. All data suggest that it must have a stellar companion from which it actively absorbs matter, increasing both its mass and its rotational energy. This hypothesis was confirmed. Orbiting the pulsar is a companion star, probably a white dwarf being slowly devoured by the pulsar. But what if this cosmic monster somehow appeared in our solar system? If J09520607 appeared in orbit around Mars or Jupiter, the nearest planet would be its first victim, torn apart and consumed by its accretion disk. The remaining planets would be thrown out of their stable orbits, drifting chaotically toward the pulsar. Earth would also be doomed. The atmosphere would evaporate instantly, and the surface would transform into a scorching, lifeless wasteland. Eventually, the pulsar would devour the Sun, and upon approaching 3 solar masses, it would collapse. But there is something even more terrifying than common pulsars in the universe: magnetars.
Imagine that only 1 in every 10 supernova explosions gives rise to a magnetar, a celestial body possessing an unimaginably strong magnetic field, the most powerful in the entire universe. A magnetar's magnetic field is a quadrillion times stronger than the Sun's. It would instantly strip Earth's atmosphere, leaving it unprotected against extreme radiation. The intensity of the radiation would be so immense that it would break the chemical bonds of most elements. Everything would be thrown into chaos, and the closer you were to the magnetar, the faster your death would be. Fortunately, the nearest known magnetar is located 8,000 light-years away, which means Earth is not in danger. However, if it were just a little closer, our concerns would be justified. If this magnetar experienced a starquake within 4,000 to 6,000 light-years of Earth, the intense gamma radiation burst could partially affect our atmosphere. The first problems you would notice would be power failures. Then the aurora borealis would appear in places where it should never be. But if a magnetar appeared in place of our Sun, you wouldn't even have time to notice that the Sun had strangely shrunk. Your death would be instantaneous. While you were watching this video, at this exact moment, more than 100 supernova explosions have occurred in the universe. Some of them left behind neutron stars, while others transformed into black holes. The universe is a violent and unpredictable place, full of objects that challenge our understanding of physics. But here is what impresses me most. Despite all this cosmic violence, despite all these monsters spinning in space, we are still here. We can still look up and marvel at the stars. This makes me think that perhaps, just perhaps, the universe is not as scary as it seems. What do you think? Do these monstrous stars leave you with fear or with more curiosity about the cosmos?
Leave your opinion in the comments. And if this video made you see the universe with different eyes, don't forget to leave that like and subscribe to the channel for more content that will blow your mind as much as a supernova. And since we are talking about cosmic explosions, you need to watch our next suggested video that is as incredible as this one. Until next time, folks, and remember, the universe may be dangerous, but it is also absolutely magnificent.